many degrees do you think are in a semicircle?
180.
You are correct. If there are 360 degrees in a full circle, in half a circle, the measure of this angle here is 180 degrees. That's 360 divided by 2. Alright, so we're going to be talking about the angle measures inside of circles as well today. Keep those things in mind. Okay, so looking at this circle, circle point B on your circle. Okay, now draw a line tracing the edge of the circle to point C. Start at point B and then following the circle, use your pencil to get to point C. Did you do it like this? No, what did you do? Did you go along the circle? Not through the circle, along the circle. How many of you did it like this? Some of you do it like that? Should have done it one of those two ways. Question?
No.
Okay. So starting at point B, what I'm saying, if you trace around the circle, there are two ways you can get to point C. You can go this shorter distance from B to C here, or you can go the longer distance all the way around the other side of the circle. We describe these as arcs of the circle. It's a part of the curve. The minor arc is the shorter distance. So on this circle, we would label that as the arc BC. It is the shorter distance around the circle. And the major arc is that longer distance. So to name it, to distinguish that from the minor arc, we pick some other point on here, and we're going to call that point D. So we're saying we're going from B, but we're passing through D and then getting to C. So we describe that as BDC with an arc over that. That's our major arc, and it is the longer distance around the circle. To distinguish, because if we called both of them BC, how would you know which one was minor and which one was major? Okay, so I have to draw. This is a B, it's kind of cut off, but I have to just pick a point D over here. I can label it and say I'm going from B to C, but the way that passes through D. Alright, so thinking about the degrees, your minor arc, we said, was the smaller distance. That's always going to be less than 180 degrees. And your major arc is more than half a circle. It is greater than or equal to 180 degrees. So that is another way to tell. If you can't tell just by looking which one is the shorter distance, look at the degrees. If it's less than 180, it's the minor arc. More than 180, it's the major arc. Next box. The measure of the minor arc and the major arc together add up to how many degrees do you think? 360. When you put them together, they make the full circle, which is 360 degrees. So if you take the minor arc and the major arc of the same circle, it adds up to 360 degrees. When we say the measure of a minor arc, we could write that as, we put a little m in front of it, the measure of BC, and that just means the angle. If you to draw a line to B and C, it's that angle between them. Questions about these definitions? And we're going to use them in the examples. Example 1, name DF. They want us to tell whether that's the minor or major arc and find its measure. So, is DF describing the minor arc, the smaller arc, or the larger major arc? If it is only given us two letters, it's describing the minor arc. And what is the measure of the minor arc? The smaller angle in there.
Pardon the interruption. Jacob Winkler's needed in the attendance office.
Alrighty.
Thanks.
The measure of that minor arc is given to us here as 40 degrees. L, go through M and get to N. Is that going the shorter distance or the longer distance? We start at L, go through M and get to N. That's the longer distance, so that is the major arc. And how are we going to find its measure? The measure of this angle in here. Yes, we know that the major and minor arc add up to 360. So we can do 360 minus 110, which gives us 250 degrees. Questions? All right, next page. We have some more definitions. So first, a congruent arc. A congruent arc are two arcs that have the same angle measure. So to describe the measure of an arc, you're describing the measure of the angle if you draw a line from each point to the center. So they have congruent angle measures. The arc length, whenever we talk about the measure of an arc, it has to do with the angle in there. The arc length is the actual distance that you would go if you're walking from one point on the circle around to another point on the circle. So what do we call the length around the whole circle? The circumference. So the arc length is a ratio or a portion of the circumference of the circle. And I'm going to show you in a moment how we can calculate that arc length if we know the circumference of the whole circle. But the arc length is the actual distance here from A to B that you would walk if you were walking around that circle. The arc length is the distance. The measure of the arc is the angle. Of ACB. So again, if we draw a line from the center to A and from C, if we start at A, go through C, start at A, go through C and go to B, we're finding this angle here, this big angle. You see what I'm talking about? I kind of butchered that picture. I'm starting at A, going through C, and ending at B. So if I draw a point going to my center of my circle from A to B, I am finding this angle. Is that a minor arc or a major arc?
What do you do with the line in the circle? I don't get that.
I'm saying if I'm finding the measure of the arc, I want to know the angle of the circle, the angle of the portion. So I draw a radius going to each of these points, and I'm finding the angle between those two radii. On this circle, it's not given to you. On most circles, it's already drawn in for you. But here it's not, so I put it in for us. We're finding the angle between the two radii at A and B. So, major or minor arc? The major arc, okay? Now what this is saying, if it's going through C, we can also find this by adding the measure of angle AC and the measure of angle CB. So, if we draw a radius going from the center to C, that whole thing, that major arc, is equal to this angle here plus this angle here. Makes sense, right? Looking at the picture. But if we know both of those two angles individually, if we put those arcs together, the angles together, we can just add them. So let's look at example 2. We're finding the measure of each of the arcs given. So the measure of arc GE from G to E, since it's only 2 letters, we know we're going to look for the minor arc or the shorter distance, which is this. Now, is that distance given to us or the angle given to us? No, but we have 2 pieces in there, right? So if from G to H is 40 degrees, and from H to E is 80 degrees, we can add those together, and the measure of the angle from GR to ER is 120 degrees. We just added those two angles in there. Okay? The measure of angle FGH. So start at F, go through G, and get to H. We know that this piece here is 40, but do we know the other piece? No, we still need to calculate that, but if you look, the very next line, we're just looking for GF. Well, we're looking for that piece. So let's call that X. Now, how many angles or how many degrees are in the entire circle? 360. So if we add up all of the angles in the circle, it should give us 360. That's what we can do here. We can say 110 plus 40 plus 80 plus X, what we're looking for, equals 360. If we add everything on the left side together, 110 plus 40 plus 80, we should get 230 plus X equals 360. Subtract 230 from both sides, and X has to equal 130. So the measure of angle GF, or the arc GF, is 130 degrees. The measure of that arc we describe by the angle between the radii. Now we have to do FGH. So what are we going to add to 130 to get FGH? We're going to add that 40, because we're taking this whole thing, so we need the 130 and the 40. 130 plus 40 gives us a total of 170 degrees. Yep. I want you to change it to DE. So at the top, we're looking at BC and DE. Those are both arcs. And then that third line, we're finding the measure of DE. There's a typo there. Get those two changes. CD should be DE. So it wants us to tell whether the measure of arc BC, this arc here, is congruent to the measure of DE, this arc here. Looking at the picture, do they look congruent? Are those the same? Well, we can find out. We know what is the measure of BC. Just looking at the picture. 58. How are we going to find the measure of DE if it's not given to us? Look at what we did in the last one. How are we going to find the measure of DE? Add up all the other angles, subtract from 360. Okay? Ready to go on to the next page. And this is where we're going to talk about how to actually calculate that distance from A to B. So if I had a circle and I actually walked around a circle in a curve, I want to know exactly how much I walked. Okay? Not from here to here, but I want to know how far I walked around the circle. That's what we're calculating in this arc length. So what this tells us here is the arc length of AB, this curve here. It is the ratio of the circumference of the whole circle, the length around the whole thing. Okay? So how you find it? The arc length of AB equals the measure of the angle AB, measure this angle here, divided by 360 times 2 pi r. What's 2 pi r the formula for? The circumference. So you take the measure of the angle, divide by 360, and then times that by the circumference, 2 pi r. Alright, so let's try this in example 3. So we want to find this arc here, AB, and I want to know what is the distance if I follow the circle from A to B. So we have to use our formula. The arc length of AB equals, and what is the measure of AB? What's the angle there? 50 divided by 360 times, and I'm going to use my circumference, 2 pi, and what do I plug in for r?